So let's discuss the procedure of hypothesis testing. Hypothesis testing is a procedure based on sample evidence and probability. Which is used to test statements regarding a characteristic of one or more populations. The basic steps in conducting a hypothesis test are: make a statement regarding the nature of the population. Collect evidence, and remember, evidence comes in the form of sample data to test our statement. Then analyze the data to assess the plausibility of the statement. So we use sample data to test a hypothesis. That means we cannot state with 100% certainty that the statement is true. The sample data cannot prove that a hypothesis is true. We can only determine whether the sample data support the statement or not. So formally, when we do this, we create a null hypothesis and an alternative hypothesis. The null hypothesis, we denote H sub 0, and we read that H naught. That's our statement to be tested. The null hypothesis is a statement of no change, no effect, or no difference. And the null hypothesis is always assumed true until evidence indicates otherwise. The alternative hypothesis is denoted H sub 1, which we read H1. Sometimes also you might see it denoted H sub A. The A is for alternative. And that's the statement we're trying to find evidence to support. So how do we set up the null and alternative hypotheses? There are 3 ways. The null hypothesis, no matter which of the 3 ways happens, always contains a statement of equality. So the first way is equal hypothesis versus not equal. This equates to a two-tailed test. So in the not equal hypothesis, H0 is always whatever the parameter is equals some number, and our alternative H1 is always the parameter not equal that same number. And if we were to draw a little normal curve here, it's a two-tailed test. So we would have a test statistic, and we're looking at the two tails. The second option is equal versus less than. So this is a left-tailed test. And for this one, H naught is still the parameter, equals, because it's always equal, some number, and H1 is the parameter is less than that number. And if we were to draw a little normal curve for it, we would have a test statistic, and we want less than, so it would be like that. The third option is equal versus greater than. So this one is a right-tailed test. And hopefully by now you know that H naught is always the parameter equals a number. And in this one, H1 is the parameter is greater than that same number. And if we drew that one as a normal curve, we would have a test statistic, and we would be finding the probability to the right of it. So for example, determine the null and alternative hypothesis. State whether the test is two-tailed, left-tailed, or right-tailed. The Medco pharmaceutical company has just developed a new antibiotic for children. 2% of children taking competing antibiotics experience headaches as a side effect. A researcher for the Food and Drug Administration wishes to know if the percentage of children taking the new antibiotic who experience headaches as a side effect is more than 2%. So what are the key words here? 2%, because that tells us what our parameter is, and more than, because that tells us what type of test we're going to have. So H naught here, we're talking about percentage, which remember is a parameter, a proportion, sorry. So we're going to use P for population proportion, and H naught is always equal, so it equals 0.02 because we have to change our percent into a decimal. H1 is our claim that the FDA wants to know if the side effects of headache is more than 2%. So that's greater than 0.02. So since it's a greater than, it is a right-tailed test. Okay, let's look at another example. And you should try to do this one on your own. It may have a different population parameter, but the process is the same. So pause the video, try this to get the null and alternative hypotheses and decide what type of test it is, left-tailed, right-tailed, or two-tailed. Then restart the video and see if you're right. So the Blue Book price of a used 3-year-old Chevy Corvette ZR1 is $86,012. Grant wonders if the mean price of a used 3-year-old Chevy Corvette in the Miami metropolitan area is different from $86,012. So here we have our H naught. Okay, our parameter this time is a mean. So we use mu, the symbol for population mean. Remember, H0 always, H naught, always has an equal sign. So in this case, it equals the mean price. H1 is what Grant wonders. He wonders if it's different. So it doesn't say whether that's more or less, just that it's different. So that indicates a not equal for our H1. And not equal means a two-tailed test. Okay, in the next video, we'll talk about the different type of errors that can happen when we do hypothesis testing.